So, you want to survive radiation. Radiation. It's lethal, guaranteed to kill you at any moment. Or is it? The truth is, radiation has several different types. If you want to survive radiation, you'll need to understand the difference between alpha, beta, and gamma radiation, and what a half-life is, and what half-lives should concern you. Radiation is scary. Our biology cannot detect it, but by understanding it, you can come to fear it less. First, let's start with the basics. Alpha radiation. It contains 4 particles, 2 of which called neutrons and 2 called protons, often called a helium nucleus. Alphas have low penetrating power. They can be stopped only by a few centimeters of air, but they deposit a lot of energy in the distance they do travel. Next is the beta particle, which is solely an electron. They have much more penetrating power than alphas, but can still be stopped by a thin sheet of aluminium and deposit much less energy than alphas. And finally, we have the gamma ray. These particles are the most troubling. Whilst they don't deposit much energy, their penetrating power is large, and they are able to travel through thick layers of lead or concrete or more if they have enough energy. If you're feeling confused, there's an easy way to remember it. Say I was to bake for you 3 cookies. An alpha cookie, a beta cookie, and a gamma cookie. If you're very hungry, you can eat the gamma cookie. If you want to, you could take the alpha cookie along in your pocket so that you could poison someone. And I would only advise leaving the beta cookie in a jar, as it's good for neither of those 2 things. But type of radiation is only one part to this equation. The other part is half-life. Half-life is the amount of time for half of the radioactive particles to decay. They have changed and are no longer the same radioactive particles they once were. So, for example, let's take a particle with a half-life of 10 days. After 10 days, we will have half the radioactive particles than when we started, and after 20, a quarter. So, when does this source of radiation stop being radioactive? Almost never. There will probably be some radioactive particles left a year after the radioactive material was created, but it will be 100 billion times less radioactive than it was before. So it's radioactive, but not dangerous anymore. So, is that it? Short half-life good? Long half-life bad? Unfortunately not. A long half-life means that a given source is decaying very infrequently. If we have a half-life of 1 million years, it can sound scary. But the mean decay time for that source is 1.44 million years. Of course, by the laws of probability, if you have enough of any material, you could receive a lethal dose from it. But in this case, you would need a gargantuan amount of material. Are short half-lives more dangerous than longer ones? It depends on the amount, but assuming the same amount in both cases, yes, particles with short half-lives are more dangerous than particles with long half-lives, but they are not long for this world. If we take our previous particle, which had a half-life of 10 days, then it will have a mean decay time of 14 days. However, if we start with 100 particles, then after 7 half-lives, we'll have a single particle left. 99% of the radiation will have gone in 70 days. So in 2 months and a week, nearly all of the contaminant is gone. However, the problem comes about when the half-lives are intermediate. If that particle had a half-life of 10 years, then 7 half-lives is instead 70 years. A long time, but short enough to emit a dangerous level of radiation over a human lifetime, and so needs to be contained for a long period of time. And by understanding the type of radiation and how long it will last, we can take the proper precautions to protect ourselves in the future. Thank you for watching this video. I hope you found it interesting and or learned something. Give me a like if you liked, and see you in the next video, if I produce one.